Question number 5. This question is of limiting equilibrium. Now, statement of the question is a particle of mass 0.6 kg is placed on a rough plane. This is a rough inclined plane which is inclined at an angle 35 degree to the horizontal. This inclined plane makes an angle 35 degree to the horizontal. The particle is kept in equilibrium. This particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in vertical plane containing a line of greatest slope. See in the diagram, the coefficient of friction between the particle and the plane is 0.4. 0.4 is the coefficient of friction. Find the least possible value of this P. This particle is in equilibrium. This particle is kept in equilibrium by a horizontal force P Newton. This is the force P acting horizontally. Mass of the particle is 0.6 kg. We have to find the least possible value of P. In this question, there are two possibilities to find the least possible value of P and the greatest possible value of P. But we have to find the least possible value of P. This system is in equilibrium. This force P acting on this particle kept the particle in equilibrium. There are two possibilities. If we increase this force P, the tendency to movement of this particle will be in the upward along the plane. The tendency to movement will be upward of this particle. If we decrease this force P Newton acting on this particle P, the tendency to movement of this particle P will be downward. So it is very clear that if the particle is at the point of slipping down, this force P will be the least. So we have to find this force P, least possible value of P. So we will consider the tendency to movement of this particle P downward, not upward. So for this is called the limiting equilibrium. The tendency to movement upward, there are two possibilities, and the tendency to movement downward. If we increase this P, the tendency to movement will be upward, then the force will be greatest possible value of P. There will be a greatest possible value of P, but we have to find the least possible value of P. So we decrease this horizontal force that acts on this particle P. We will decrease it. We can find the least possible value of P. So we will consider the direction tendency to movement of the particle P downward, not upward. So we are making the diagram once again, and first of all we will represent all the possible forces acting on this particle P. We are making the diagram here. Inclined plane. This is angle 35 degree with the horizontal. This line is horizontal. This is inclined plane. and the particle P, and the particle is here. This is the particle, and this is the horizontal force acting, horizontal force of magnitude P Newton. Mass of this particle is, we will write here, mass of the particle is 0.6 kg, and the coefficient of friction, since this is a rough plane, this plane, inclined plane is rough, so there will be a friction. So coefficient of friction given, that is 0.4. We represent the coefficient of friction by mu. Mu is the coefficient of friction. Now we will represent all the possible forces acting on this particle. This force P acts horizontally, but we will resolve this force P and find two components. One component along this plane, one component in the direction of movement of the particle. Particle is moving along the plane. One component along the plane and one component is perpendicular to the plane. So this is the resolving, this component and this component. So we are resolving this uh, P force. One, this component is perpendicular to the plane and this component is along the plane. Now this angle is same as this angle, 35 degree. So we write here this angle is 35 degree. Now the component opposite to the angle is 35. This component will be P sine 35, P sine 35, or this component is P cos 35, P cos 35 degree. Now the weight of the particle, other force acting on this particle is the weight which is acting vertically downward. Weight of the particle is acting vertically downward. This is mg, m is given. Now we will resolve this weight and find two components once again along, one component along the movement in the direction of the movement of the particle and the other component along the other component is perpendicular to this plane. This component is along the, this component is along the plane, perpendicular to the plane, and this component is along the plane. So we are resolving this mg along the plane and perpendicular to the plane. These are the components. This component is perpendicular to the plane. This component is along the plane. Now this angle is again 35 degree. Since this angle is, according to the angle properties, this angle is 35 degree and this angle is also 35 degree. So we will write here 35 degree. So now the components and the one another force that is also very important, that is the, according to the Newton's third law of motion, reaction of this particle and the reaction of this particle, the reaction of the plane on this particle is vertical to the plane. We are representing it by uh, this is R. Normal reaction is represented by R. Now, these components we will write here the components of the weight. So, this component is mg cos 30, mg cos 35 degree, and this component is mg sin 35. Now we have mentioned all the possible forces acting on this particle which is kept in equilibrium by this force P. Now we use here, we have to find the least possible value of P. So to find the least possible value of P, I have already mentioned that I have already explained that we can find the least possible value of P if the tendency to movement of this particle will be downward. So a tendency to movement downward, tendency to movement downward, it is just limiting equilibrium mean this particle is just about to slip up or just about to slip down, but since we have to find the least value of p, so we will consider the downward motion, tendency to movement downward. So mm, when we will consider the, since this uh, plane is rough, when a tendency to move, since the tendency to movement is downward, so direction of the friction will be upside along the plane. So we are representing the uh, force of friction in the opposite direction of the movement. Movement tendency to movement is downward. So now we are using here the Newton's second law of motion. Since the system is in equilibrium, so acceleration will be zero. Acceleration is zero. Now we are using Newton's second law of motion, which is F is equal to ma. But in this case, in this question, F is the net force. First, we will find net force since the tendency to movement is downward. So we will write this weight component acting along the plane downward. mg sin theta direction is downward to along the plane, and the two components p cos 35 and f force acting uh, up the plane against the movement of the particle. So show equation of motion by using this and Newton's second law of motion, net force will be mg sin 35 degree minus P cos 35 degree minus F is equal to 0. Or simply we can write it also multiplying this whole equation by negative 1. So mm, we can write it in this form also, F plus P cos 35 degree minus mg sine 35 degree is equal to 0. Now we will find F. F is the force of friction. Uh, Force of friction will be equal to, F is equal to mu R. Mu is given in the question, that is 0.4. Point 4. Mu is the coefficient of friction which is given, and we have to find R. In the diagram, this R is acting up the plane. This is the normal reaction acting up the plane, and there are two forces acting downward, this and this force. So R will be equal to the sum of these two forces. So first of all, we will find R. R is equal to P sine 35 degree plus mg cos 35 degree. So we can find F. F is equal to mu R. Mu is putting here the value of mu and R. So F is equal to mu, that is zero point 0.4. R is P sine 35 degree plus mg cos 35 degree. Now putting here, now this is F we have found. We putting the value of F here, we can find the value of P. Value of F is this. Later on we will simplify it. 0 point, putting in this equation, mu R is P sine 35 degree plus mg cos 35 degree plus P cos 35 degree plus P cos 35 degree minus mg sin 35 degree, mg sin 35 degree is equal to 0. Uh, Here the right side is 0 because acceleration 0, because the system is in equilibrium. There is no acceleration because the system is in limiting equilibrium. Now we will simplify this equation and easily find the value of P. So multiplying this zero point 0.4 by these two terms in the bracket, we get 0.2 by using calculator, 0.2294 P plus 1.966 plus P into cos 35. The value of cos 35 is uh, 0.819. Next, mg sin 35 degree, m is given, g is 10. So multiplying by sin 35 degree, we get after simplifying 3.441 is equal to 0. Now we have now we are adding these two terms involving p. So we get 1.0484 p, adding the p terms, minus 1.966 minus 3.441. This becomes 1.475 is equal to 0. From here, 1.0484 p, 1.0484 p is equal to 1.475. From here, p will be equal to 1.475 over 1.0484. 1.0484. Finally, the value after simplifying it, we get the value of P, that is 1.41. This is the least value of P. Least value of P is 1.14. This is the value of P 1.41 Newton, because this is a force P. So the least value of P, the unit of force is Newton. So 1.41 Newton is the answer.